Welcome, dear viewers, to UpClose The Engineering Chronicles, where we invite accomplished engineering professionals and trace their incredible life journeys through deep and engaging conversations. Today we have with us Dr. Asad Abu Bakar Ali, Director and Singapore Site Lead for Merck and Incorporated, or MSD. Dr. Asad, thank you so much for being with us.
Welcome,
Thanks.
Asad.
Thanks so much for the opportunity and thanks for having me here.
Yeah.
Right. So, how are you feeling, sir?
That's a good.
So I'm feeling a little nervous with sitting here with all of you. I'm not sure if I'm accomplished, but I enjoyed my journey. So I'm happy to share.
Right, definitely.
Yeah, I think you don't have to worry. As again, this is our first shoot actually for Up Close, right? So we're also feeling a bit giddy. So we'll get through this together, hopefully.
Yes, we will. So to begin with, in your words, who is Dr. Asad and what does your daily life look like?
So in my own words, Dr. Asad is someone I'm pursuing my passion, and I love pursuing what I think should be the right thing to do. And in my day-to-day life, I'm just fortunate to be in an organization at MSD where I have the opportunity to really align with my passion in terms of what I do in every day. And that's really to do something for people, do something for healthcare. So my day-to-day is all about thinking about how can I help those patients and how can I work with people to make that connection.
I can attest to that because I see it every day. You are indeed a role model. I feel like at this office, day by day. And actually, you said something about passions, right? So one of the goals of Up Close is that we really want to get to know you as a person, not only as your professional career, but who is Asad and where did he come from, right? So I guess I would like to ask you, like, your passions, how did they come about? Was it something in your childhood or during your uni days? I mean, we're all uni students here. Hopefully the viewers will be uni students too, and maybe others too, right? So we're not excluding anybody here. So yeah,
So where did those early sparks for your passion begin from?
Okay, so let me start there, right? Which is, I'm not a baby genius. Neither my mother showed me a sort of crystal glass, and I've seen that light rays being, splitted, and then I became a scientist. Not exactly,
all right.
but it's a lot that comes from people believing in it, people believing that you can do it. So in my childhood, there's this interesting conversation. So my mom was a little sick when I was this little boy, but she used to love listening to music, right? And if you all are pretty young, so you probably haven't seen that tape recorder where there's a tape. Right? So we had a tape recorder, and the tape recorder always breaks down, and the tape gets jammed. And then my mother said, "Oh no, my son, who will be a scientist, an engineer, who can fix it." And at that time I was 6 years old. I still remember. And I said, "Oh yeah, I need to help my mother, and she's trusting me." So basically, I would open up, and then she didn't stop me. So I would use a screwdriver to open up the tape recorder inside. I would see the pulley and the gear system. That was exciting. I screwed it up, but then eventually I managed to put it back again. It's not rocket science or anything. Basically, it's all the instruction. But that gave me confidence. That gave me confidence that people believed in me, and hence I have to deliver. And I started believing that I can do it. So fixing the tape, if you have known it, right, you need to put, like, the broken tapes, if you have seen it. Basically, you need to put tapes below the tape to fix it. And we had this recording system on that cassette player, and I would just play with that by putting a paper and see if it records, if it stops recording, and what was the optimal thickness of, what kind of tape to be used so that it runs smoothly through the pulley. Right. So again, that's all about people believing in me. So my mom thought that I can do it, and then I thought, yeah, I can do it.
Right. So, that's a very touching story. Like mothers, of course, they are like the first idols and show you. So from that story of 6-year-old, let's dive deep into your school days. What was your schooling like and growing up? Where were those other sparks for your passion which led you here?
So so yeah, I think the other sparks were uh, so from the early days, right? I would, people talk to themselves, right?
Mhm.
So when I talk to myself, I say, okay, the scientist Asad is talking to scientist. So let me just be honest. So
Mhm.
from there, I thought that I wanted to be an engineer. Actually, there was a time when I wanted to be a physicist,
Ah, right.
like
like a theoretical physicist.
Oh.
That's what my passion was.
Okay.
I told my dad. My
Uh-huh.
dad said, "Well, I come from Bangladesh, right? So, and in Bangladesh, being a theoretical physicist, you might not have a career to build because there's not that many opportunities. I'm not saying there isn't any, but they're just so much limited.
Mhm.
So then, engineering tends to be somewhere in the middle where you can play with the technology
Mhm.
and yet you can pursue that science and physics. I really love physics.
Yeah.
So that's how I became an engineer.
Ah,
So,
right.
yeah.
For this passion of physics, just curious, was Meghnad Saha someone who came into like your light for that?
That's right. So actually, some of the leaders, like for example, some of the scientists,
Mhm.
Meghnad Shah,
Mhm.
Jagdish Chandra Bose,
Mhm.
right, who is a Bose-Einstein particle, they are Bengals, right? Some of them have studied and
Oh, I see.
so that's part, right? At the same time, I think the fact that you can do it, right? And people told me that physics is the toughest subject, so I
Yeah.
thought, why not go after that? So that was part of it too, right?
Yeah.
But maybe it's not correct that physics is the toughest subject, but people share their experience, and I thought that sounds good. And these are all people that they are so acclaimed, so are accomplished.
Hmm.
So I thought that maybe I wanted to study physics.
So,
Right.
what did the challenge sort of motivate you in that sense?
So that's right. So in a way, I think going back to what my mother said, right?
Mhm.
My mother, if she said it's easy, you can do it. Probably I won't do it. It's tough, but you can do it. So I went after that. So
Okay.
that motivates me. So basically, going after a challenging problem and trying my best, giving my best to solve it is something
Mm.
I'm passionate about.
Right. Just to let our viewers know, so where Dr. Asad comes from, the whole land of Bengal, Indian Bengal, and Bangladesh has a rich heritage of highly accomplished scientists, physicists, engineers who have contributed greatly to the.
Including yourself, of course.
So, yeah, we have someone who comes from that very legacy, that land. And I'd encourage our viewers to go and read up about them. So, moving on, Dr. Asad, coming to your school, uh, when was the time, like, was it middle school, high school, when you had to sort of decide, okay, this is what I have to do, this is where I have to go?
So in back at home, right? So up to A level, you can keep all of those passions. Right?
Open all the doors
All the
open.
doors open.
Yeah,
Okay.
yeah.
So long as you pick the right subject. So I took for my high school, right? For my A level, I took physics, chemistry, math, and bio.
I did that too. For IB, I did that too.
Right. Okay. So keeping the bio. So actually, after my high school, then
Mhm.
back at home, how it happens, right? Sometimes at times your parents
Mhm.
have strong, uh, strong opinion or thoughts about what you should become, right?
Yeah,
Right.
So
yeah.
my parents thought that I should become a doctor.
Okay.
And I
Like a
wanted-
medical doctor?
Like a medical doctor.
Okay.
Ah,
So then, usually, in the universities in Bangladesh, you have an entrance exam,
mhm.
and for acing that entrance exam, you really have to study very hard and very focused.
Mhm.
So you have a situation of either or. So
Hmm.
either you pick medical and prepare for a medical school entrance test, or you pick engineering.
Mhm.
And here I am in dilemma, right? I wanted to be a physicist,
But
parents will only support for medical entrance test. So
Yeah.
I said, okay, well, I'll do my best for the medical entrance test,
Mhm.
but I'll self-prepare for the engineering entrance test.
Oh wow.
So
Wow.
then,
Did your parents know about that?
They know.
Okay.
They know about it, but basically they didn't stop me because as long as I'm not asking them to fund, so they were happy that they didn't have to support both. But I was I was doing okay for the medical entrance test, and in fact that turned out to be well. I got into the medical school is the one that was my first choice, also the top one in Bangladesh, Dhaka Medical College. I managed to get into that. But then at the same time, I also managed to get the electrical engineering back at home in Bangladesh. So then I went to my dad and
Another dilemma.
dilemma, but he was very supportive. Turns out to be that again, right? The parents' support comes this way. My father is a medical doctor himself, so he did have the dream that my son would become a doctor.
Right.
But he never really forced when the situation came, right? So he said, yeah, you should just go and join the engineering school. So then I started back at home in Bangladesh. I spent one semester first in electrical engineering in Bangladesh. And then I got an opportunity here in National University of Singapore. Then I moved here.
All right.
So that's why the decision was done, right? That I would study mechanical engineering because now in Singapore, I got into mechanical engineering and started.
So, how was that switch like? You started off with electrical engineering in semester one. Then, how did you transition to mechanical here in the US?
So at that time, right? I guess back in year 2000, right? That was the time when I came here, and during those time, US was really trying to expand and gain,
International
international
students.
students, and very, they were rather taking the first step to go and find. So they used to have this entrance test in Bangladesh. So they were going and conducting entrance tests. And I happened to know about that entrance test. I applied, and then through that entrance test, I got an opportunity to study here for engineering. First year common engineering, and then I picked mechanical engineering in my second year.
Okay. Why mechanical engineering?
Given what you're doing now, it seems to be quite a jump between mechanical and the pharma business of MSD.
Well, so I think part of it is journey, which surely we're going to probably talk about a little bit. But I think when I started mechanical engineering, I thought that's the best thing to do. So that's why I started mechanical engineering.
Best thing in
It was like the
terms
top field at that time.
One thing is top field. The other thing is at that time it was time for back in the year 2000, right? You say what is the coolest thing you can think about for engineering innovation, and people would say, "Oh, robotics." Right?
Oh,
okay.
What subject is closer to the robotics? So it's basically electrical engineering or mechanical engineering, which sort of covered most aspects. So that's the reason why I started mechanical engineering.
Right. Okay. And then, so now mechanical engineering, you're here in Singapore. Let's pick up from there. How was the journey from there like?
Mechanical engineering to
so like
Beginning at mechanical engineering and Singapore. Yeah.
okay.
I guess what you're trying to say is the transition period between moving from Bangladesh to Singapore in 2000.
Wonderful. Thanks for clarifying. Yes. So in 2000, when I moved here, well, I didn't come here on a scholarship, on full scholarship, right? And then there were unfortunate episodes in my personal life. My dad had a brain stroke.
Oh.
So then my first few years at NUS was a little challenging. Singapore is an expensive city.
Yeah.
And yet I had to sort of do my best to support my family. So I was doing part-time quite a lot.
Oh, okay.
So 16 hours minimum I was working at. I was fortunate to get opportunities at ISPs, internet service providers.
Yeah.
Early days of internet at that time. So I used to work at a data center at night.
Oh, wow.
Server, they would call, so basically a call center.
Yeah.
Provide the tech support.
Mm.
So that was and then weekend I was giving tuition and I was yet enjoying my studies. So it was I would say it was a big transition in a way from my personal aspect, from that financial aspect. From cultural aspect, right?
For
It's
sure.
also a big transition, as you can imagine.
Right.
But I think let me highlight what was supportive, right? Because challenge is challenge, but what's supportive, I felt one thing supportive is that Singapore's ecosystem uh, for multicultural international students, multicultural setting, uh, welcoming people, US's interest to really support all the international students and do their best. I think all of these things played together.
Right.
It was in no time I realized that I finished my undergraduate degree with a specialization in control systems and robotics.
So but that's still very different from what you're doing. So is there a big gap in a shift of mindset or opportunity came?
Yeah, so again, I mean, certainly, I mean, I don't do control systems and robotics today. I mean, we're in healthcare. Uh, there's a huge difference, huge gap, right? So I started my first job as a software engineer um, for real-time operating system, right? Part of the control systems and robotics and mechanical engineer, what you would do, if you're good in programming, you would go after real-time operating system, trying to make those machines
Yeah.
that are used for semiconductor manufacturing process.
Semicon manufacturing. So
Just for context, he's currently interning at Micron. So,
yeah, so,
that's why
we have a bond over there. Right. So, you mentioned earlier that you wanted to kick off and go all the way in semicon itself. Why that? Like, why that early instinct to go in semicon? Yeah.
So that's interesting, right? So during my final year, right, I figured that that a lot of things happening in Singapore for semicon, but there was one thing that really got my attention, and which I haven't gotten back to yet, but one day hopefully I'll get back to it. Is NIMS and MEMS devices and lab on a chip. And if you think about the time I'm talking about in 2003, that was something. It was so much powerful because the concept started coming at that time, and that was the first time when Liga processes were sort of put in place. Liga is basically is a
Just for our viewers, could you like explain to the ordinary layman what all these things mean and how like significant were they during that time?
I'm quite clueless.
Yeah.
Sorry, that'll be me. That person will be me.
So for normal semiconductor processing, right, you are working with silicon wafers, and basically, typically you are using processes like lithography processes and normal optical processes, which you're going to apply for etching and making those semiconductor patterns that you need for transistors and junctions for it to work as an electronics. Now, for lab on a chip devices, you need to have different kind of materials and materials that have different properties. And for those different properties, normal optical light for that those processes are not sufficient. So you need to use, uh, X-ray and basically different sort of beam, more powerful beams for doing those processes. So
More powerful beams to imprint the circuitry.
circuits, right? And at the same time, you also need to have, let's say, deep channels, right, for microfluidic channels on a different material. So, and if you're going to have another thing, which is now, electronic circuit is essentially a digital circuit, right? Everything happening is digital, and then the analog because the rest of the world is analog. So the analog digital connection happens with the connection, the leads that are exposed to the world. Now, for a Liga, I'm sorry, for a MEMS or NEMS device or for a lab on a chip device, it's encapsulated and packaged together, right? Because the analog world that you're going to sense has two analog parts. One is the outside world, one is inside.
Yeah.
And then you have the lab on the device that's going to do that. So manufacturing this is way more complex compared to just microelectronic device.
Right.
So that and at that time, if you think back then, it was so much impactful. There was so much hope in it that it will change the way we do many things today. We talk about healthcare, and even though I gave up my medical school, I still had the passion for healthcare.
It was reigniting.
Reignited. So I thought that what really got my attention is lab on a chip again. And I thought,
Just to take a step back, what was lab on a chip, and to a layman, how could you explain to our viewers its significance and
For those
how
of-
was it revolutionary back then?
For those of y'all interested in semicon, this is for you. So listen
Yeah.
up.
so well, lab on a chip device is something interesting, right? Which is, let's say, okay, maybe I'll start here, right? Which is, the phone that you carry in your pocket today, right? Which is about 200 something gram,
Right.
Like just 50 years back,
Mm-hmm.
all the functionalities that you have in a phone
Mm-hmm.
it's not 200 gram. It's a
Whole brick.
Whole brick, yeah.
Few tons.
you have
Right.
a compass, you have a
Mm-hmm.
blood pressure monitor, you have a
Yeah.
navigation device,
Correct.
you have a video display, you have a CRT television at that time, right? So putting all of this things to a couple of tons of device that you're carrying.
Mm-hmm.
So
So these are all like basic medical equipments like blood pressure machine, CT scan, X-ray. All of these
all
are
of this
separate devices. Lab on a chip was
now things are put together. So I'm
Uh-huh.
coming to that is that now in your phone you have you have a 3D accelerometer, right?
right.
Which tells all the motions and you have a gyroscope inside, right?
Yeah.
So now a lab on a chip device is going to do the same, which is today if you have a successful implementation is going to do the same. If you have a drop of blood today
Mm-hmm.
and you put that drop of blood into a 1-ton machine,
Mm-hmm.
and that machine is going to analyze and going to say that your triglyceride is this, your HDL is this, your LDL is this is your blood count. But that machine itself is a couple of tons.
Yeah.
Now, can we shrink that device and encapsulate that
Into a single
in a
chip.
single chip, which
Whoa.
is now on your now mounted in your home door,
Right.
Yeah.
in your closet?
So that technology hasn't taken its full potential yet, is it?
I think that hasn't taken a full potential, but
Mm-hmm.
just remember one thing.
Mm-hmm.
We had this experience during the COVID, right?
Right.
Which is a PCR test. Of course, they are not the same test. But
Mhm.
think about the microfluidic channel and doing the the ERT test,
Mhm.
right?
Yeah.
So basically, that's an example that you can sit on your desk and you can do the test.
Okay.
The other kind of thing is this, right? Couple of examples are already there. You can already start to hear, like for example, measuring blood glucose from your sweat.
Uh-huh.
And
Oh yeah.
So things like what Apple does on Apple Watch, measuring your heartbeat, and other such healthcare devices, they are like steps in the larger
steps towards that.
steps towards that.
And then if you think you are a chemical engineer, so
Uh-huh.
you will get this very well.
Chemical
Right.
engineers.
Is that the physics,
Uh-huh.
right? Interaction with physics.
Uh-huh.
Since physics is one topic, right? Interaction with physics seems to be
Mhm.
different from interaction with chemistry,
Right.
Yeah.
right?
Yeah.
For example, using Apple device, right? Today, most of the Apple watches, what they're doing, of course, innovation is going forward.
Mhm.
But the current status is that it is detecting physical interaction, right?
Okay.
Yeah.
For example, it's measuring your heart rate.
Uh-huh.
It's looking at your oximetry level,
Mhm.
right? How dark your blood is. Just looking at that by shining a light, it's figuring out that is it the phase of a beating heart, and that's how it's getting that heart rate.
So at present, you are saying all the interactions are heavily physics focused,
Physics focus.
meaning using things like interactions with light or
Heat.
with signals or heat or other such physical interactions or motion. And then, okay.
And then the biology is said to be a little more complex than that,
Uh-huh.
because then you have
Yeah.
both physics and chemical interaction.
Right.
Like for example, just using physics interaction, you may not be able to, or at this moment at least, we don't have an understanding
Mhm.
how you can tell, the blood glucose level. You need to have a chemical interaction.
Yeah.
So that means you need a blood drop of, sweat or blood or whatever, something that carries that signal,
Mhm.
and that signal now needs to go inside that lab on a chip device. So
Yeah.
basically, now microfluidic device has gone inside,
Mhm.
and now that little bit of fluid is sitting now inside the device,
Mhm.
but the device must have physical or chemical interaction with
Yeah.
that source of signal
Right.
to read it out,
Yeah.
right? So that's what the challenge is. So
Mhm.
basically, if you have a, you know, the field is progressing. We're not there yet, but hopefully one day we will be able to, you know, predict if someone is having cancer with high accuracy, just having a couple of drops of blood, and you can do the test at home.
Something as non-intrusive as possible, very highly, what do you call it? Convenient and all that.
And non-invasive. So few things, right? It has to be non-invasive. It has to be inexpensive,
Yeah.
and it has to be broadly available and broadly applicable.
Hmm.
And that's where you can make it available to each and every people,
Right.
so that they can take charge of
Right,
maintaining their
right.
own health. Right?
Right.
Like the same way.
No wonder. No wonder. Like, I mean, now I understand why back in 2004 this really caught your attention, because I mean, literally the hope that this tech brings with it. So back in 2004, this light, this hope is what caught your attention. What brought you to this light? Like, kind of diving deep into from your first semester in NUS, what were your experiences that kind of led you over here? Yeah, who were the professors or other inspirations which, within mechanical engineering kind of guided you towards this specific domain?
Well,
Source of inspiration like that,
a
yeah.
two sources of inspiration, right? One is a Bangladeshi professor who is actually, teacher at NUS. So he was also my undergraduate supervisor as well as my PhD supervisor. So one thing I didn't tell about my early life is my grandfather was, besides my mother, was also a strong inspiration.
Oh, okay.
And he had the same kind of thinking process. Actually, but it resonates back to the same thing, is that believing in him, right?
Hmm.
So his name is Professor Mustafizur Rahman,
Mhm.
right? So he was my supervisor at NUS. And during my third year, right, basically during my, as I said, I needed money, right? So
Yeah.
during vacation, instead of going home, I would go to him and say, "Can I do something?"
Hmm.
He would just give me anything that comes to his mind, right? So being a third year student, he had tons of masters and PhD students. He told me, "I'm going to give a talk in India or Prague. Can you prepare a presentation?" And I had no clue what he's talking. And he says, "Here's a hard drive. I have some slides. Just go and figure it out." That's all that he says. And then, it's a challenging task, right? But yet, I know what he is dreaming about, right? And he was very keen on doing this
The lab on a chip.
lab on a chip, and developing the enabling technologies that can bring forth the manufacturing that can manufacture this lab on a chip. So he was very heavily involved in micro and nano machining, right? So he would ask me, and I'm a third year, undergraduate student. I have no clue. But then he gave me this challenging problem. So he was very inspirational. With him, since he was this kind of inspirational, he got he has a Korean postdoc in his lab, Dr. Lee Man-sak. And he was the other person that, inspired me to go after, go after taking on challenging tasks and, enjoy doing what we're doing. So he was very inspirational too. And together, Prof. Rahman actually, he had a spin-off company.
Okay.
That spin-off company is called Micro Tools Private Limited. And during my undergraduate, right? So through that interaction, I landed on my undergraduate project, and they had an order from a couple of universities as a spin-off company that they were buying this machine that was doing that enabling technology for micro and nano machining. And my final year project was to develop controller for those machines.
Oh.
So that was really wonderful. I enjoyed that time. But going back to what you said, those two figures were extremely, extremely supportive and inspirational for me.
Okay.
And I think Prof. Rahman is someone that I would like him to listen to this podcast.
Hello, Prof.
Hi,
Prof.
We'll search him up for sure. Am I getting the name correct, Prof?
Mustafizur Rahman.
Prof. Mustafizur Rahman.
Yes.
Right. So, I mean, that's quite an interesting journey. You started off in NUS, then you went to Prof. Mustafir, essentially to get work in his lab. and that's where you got introduced to Lab on a Chip with the other Korean postdoc prof.
Mhm.
So he became a
Yeah.
professor at NUS before going back to Korea. His name is Dr. Lim.
Dr. Lim, okay. And then you essentially toured with Prof. Prof. Mustafizur on his tours and lectures across the world, essentially.
I didn't tour him, but basically I was making the slides.
Your slides were seen by many people then.
Well,
Okay.
I don't know how much change he had to do afterwards. I'm sure he had to do significant modification to it.
Yeah.
But I was,
Mhm.
I was going after what he assigned me to do,
Yeah.
right? So
Yeah.
that was really exciting.
So by year 3, you were kind of solidly grounded into Lab on a Chip and going towards this med tech, right?
Going towards semiconductor manufacturing,
Mhm.
and I had this dream in my mind that I want to do this semiconductor manufacturing for health.
For medical.
For healthcare.
Okay. So that's why semicon and medtech. I can see how like your passion for physics was constantly reinventing itself and manifesting in
So
many forms,
something
right?
that I thought about is that I feel like since it's the dream that drives you forward, right? It's not your starting hand. It's not necessarily what you're studying, right? So as long as you have that dream and you work on it, you go for it, you'll be where you are today. Like
That's-
is that how it works? Would you say?
Well, that pretty much exactly it works. Maybe I'll just tell you another transition point.
Mm.
And I think for the students, I think that's, again, with all humility, right?
Mhm.
Whatever I am today, that's only possible because, I tried my best, did my best to go after my dream.
Mm.
So really be passionate about, what you want to do, what you want to achieve, and go after that. Give your best and go after that. Don't worry about whether you fail or succeed.
Mm.
Because if you evaluate that probability, right?
Mhm.
At the beginning, it is always 50-50.
Yeah.
Right.
Yeah.
Who knows who is going to succeed and who is going to fail?
Uh-huh.
But you are the one who can determine that you will succeed and not fail.
Mm.
So the transition point is, I'll share this, is that, so well, I joined semiconductor company and then I worked for 2 years. And then I thought, well, my healthcare is not coming.
Right, yeah.
It's not doing what I wanted to do.
Like semicon and like huge interest in medtech, but your first job was as a software engineer, right?
That's right.
Wow.
Could you tell us more about your first job and why did you choose that, like right out of college?
So, well, so part of it was for my first job. Part of it was that I graduated in 2004.
Uh-huh.
Economy was bad, right?
Oh.
And there was limited opportunity. But now, if I think back,
Mm-hmm.
would I have chosen anything else?
Mm.
Actually, I would have landed in the same sort of job
Mm-hmm.
that I landed.
Mhm.
And what I was looking is something that involves embedded systems
Mhm.
because healthcare devices,
Mm-hmm.
wearables, those things require embedded systems.
Just for our viewers.
What's that?
Embedded systems.
What's
Yeah.
that?
So,
Yeah,
Maybe just
like,
briefly-
what's embedded systems.
Briefly describe it to me and the viewers.
so well, embedded systems is like, okay, well, you have an operating system,
Uh-huh.
which is not really a computer operating system,
Uh-huh.
and you have a motion controller, and I would say instead of motion controller, sorry, it's a microcontroller instead of a microprocessor,
Mm-hmm.
so that the system itself is standalone
Mhm.
and it has ability to read the analog signals that are coming from the environment,
Mm-hmm.
the nature,
Mm-hmm.
do digital processing
Mhm.
and act upon it.
Okay.
But it's not computer, right?
Mhm.
Because if you
Right.
think about the conventional computers, it has only two human-machine interface: the keyboard and the mouse. The
Yeah.
things and maybe microphone
Yeah.
and camera to that.
Camera today.
But other than that, it's not a heavy human-machine interface device.
Yeah.
Whereas in embedded systems, an example would be like, for example, I'm just blanking out on the embedded systems. Hopefully this doesn't come. Let me come up with a good embedded systems example.
But qualitatively, if I understand correctly, essentially, instead of taking the phone example, the graphics card, the camera, all of these being separate systems, embedded systems are everything embedded onto one.
onto a same device. Your same device is a standalone, but at the same time, it has a interaction with, uh, you know,
Mhm.
interaction with the external world that is able to be done.
Okay, so rather than parts coming together to form something like a phone, embedded system is designed with a specific end objective in mind, and then you put all components together which work cohesively towards that end objective to the extent they are not separate systems but work cohesively together.
That's right.
Okay.
Semicon guy.
You have
This is the semicon guy right here. Yeah.
So, so as you can imagine, right? So that particular definition of embedded system is essential for any wearable medical healthcare device.
Okay, all
And
right.
then it has to be a semiconductor.
Uh-huh.
So that's why I was interested in semiconductor.
So that's why, like the first job you had, the company was working in embedded systems.
The company was actually a semiconductor equipment manufacturing company.
Okay,
okay,
lab applied material.
okay.
What was the
So
company?
it was called KNS, Kulik and Sofa.
Oh,
And
right.
they were doing
Uh-huh.
wire bonding. So basically,
Okay.
they use pure gold wire to bond the internal IC world to the external world. So it's a back-end manufacturing process because applied materials and others are in the front end,
Mhm.
and this was at the back end, encapsulation and packaging.
Okay.
So, but why embedded there, right? Because the system itself
Mhm.
was having multiple different components, right?
Mhm.
Yeah.
And embedded programming and real-time operating system,
Mhm.
so that you have real-time response,
Mhm.
and all of this was coming together.
Hmm.
So that was an exciting opportunity for me because uh, I get to experience back in 2003 or 4, right?
Mhm.
Real-time programming,
Right.
you know,
The techie,
techie thing, right?
real-time systems
Real-time
and
systems
um,
and multitasking, right?
Uh-huh.
Right.
Thread synchronization, multitasking in computer processing,
Uh-huh.
microcontroller operations using multitasking and multiple threads
Mhm.
was very exciting at that time for me.
Okay.
Mhm.
We should explore that a little bit. So that was an opportunity for me to learn a little bit about that.
All right. So from there, at what point in your job did that kick come in that, this is not really going to my medtech interests? And from there, how did you take the decision to pivot?
How did the opportunity actually come in the first place?
Well, the opportunity came. It was look for job opportunities. Right? We apply Sunday recruit.
Mhm.
You know what I'm talking about.
Excuse the noise if it gets picked up. There's some renovation, right, going on? Yeah. Sorry about that.
So back in 2003 end, when I graduated, right,
Mhm.
the economy was really bad. Singapore just came out of SARS.
Right. Oh, this was.
It's
Oh.
COVID-19's previous version.
Yeah.
Just got out of SARS back in 2003 end.
Mhm.
And then there was also financial crisis due to Iraq war and
Right.
Afghanistan war.
Mhm.
So
Right.
it was a depression at that time. So basically, look for recruit
Mhm.
on Saturday morning newspaper, and go
Yeah, they
for
did it on newspaper back then, yeah?
Newspaper was your
LinkedIn was the
LinkedIn,
thing.
your Indeed was your
newspaper was
everything.
LinkedIn. So the first thing you do is Saturday morning, you wake up, right? You go to 7-Eleven, buy the recruit.
Mhm.
There were, walk-in interview. I probably don't have that concept, right?
Mhm.
They will advertise for walk-in interview. Means 7 o'clock you read it. By 9:30 you are out there for interview.
Oh, okay.
Okay.
Right? And then many of those walk-in interview used to happen on Saturday morning.
Right.
The first round they will get it done.
Yeah.
So actually such an opportunity came, and I saw this company, and in fact, this company has a long history, Kulik
Yeah.
and Sofa, and they have a
Right,
history of making the first wire bonder and first commercial, commercial electronic device. So
Oh.
they had initial partnership back in 1950s with TNT Bell Lab.
Okay. So they go all the way to Shockleys and
Shockley, that's
Yeah.
right. So they partnered with Shockley and all to prepare to make the first generation the semiconductor.
Okay.
Yeah.
And as I was going from, at that time, of course, you don't have this mobile device that you Google, right? As I was going for my interview, you just, at least you Google, you on a computer, but you can't do it during the computer.
Yeah.
Right?
Yeah.
Right.
I Googled and I saw this rich history. And of course, my mind says, I wish I get an opportunity there. So, and it so happened that, they picked me. So I was fortunate and I enjoyed my 2 years of work there.
Okay. Yeah, I mean,
The MSD opportunity came way later, or
Way later.
way
that's
later.
after your PhD, right?
That's near the finishing of my PhD.
Oh, okay.
Yeah, like, I mean, now that you walk us through that, these were quite consequential times. 2003-4, Dr. Asad is well embedded into lab on a chip.
Was that fun?
No,
Embedded.
kind of a fun. So Dr. Asad is well embedded into lab on a chip, which is an embedded system. At 2003-4, you have the SARS epidemic, you have the Gulf War, and yeah, like kind of situations what are right now, right? A lot of things happening, pretty consequential time.
Similar. I mean,
And
what was
yeah.
going on right now in Europe?
Our viewers will connect with you a lot because we live. But
You'd be
again, that what's
surprised, yeah.
inspirational is you were clicking onto this hope that lab on a chip brought, and then you started with Semicon. You got the company that you desired, one with a rich history in semiconductors. How did that end, and then where does your PhD begin?
Right. So here's the thing, right? So after I joined there, they were using gold wire.
Right.
So it's 99.9% gold, pure gold.
Oh, wow.
And then the project came is that can we replace this gold with copper? And that was the hottest research project that the company was involved. And I got really, really excited. I went to my manager and said, "Can I work on it?" And he gave me that opportunity to work on that copper project. So basically, they formed a task force.
Yeah.
And that task force team was put to do that copper project innovation.
Okay.
So it can be low cost, and of course there are some challenges. Like for example, copper heats up. The conductivity is not as good as gold.
Right.
So, but then solving those challenges required you to work in a multi-dimensional setting, right? For example, the task force really was put together by bringing software engineers, process engineers, electrical,
Chemical?
mechanical. In fact, there are a lot of chemical engineers.
Let's go.
It's because the wire bonding process itself has a lot of complexity, right?
Right.
You have to, there are mathematical models of that copper ball or gold ball, and then you have to pump it, you have to rub it against ultrasonic generator, etc. So a lot of chemical engineers were actually involved in that process physics. Because,
So just contextualizing everything a bit, KNS was the semiconductor company that made semiconductor manufacturing equipments. And what did it do specifically was?
They were doing wire bonding process. And wire bonding process is basically connecting the internal semiconductor IC world to external domain, where you have the leads to give input and output signal from the world.
So their core objective was connecting semiconductor chips to the outside world, essentially managing that outside world interface interaction.
That's right.
At that time, they were working with gold. And then came this exciting project. Of course, I'm presuming because of cost reasons, to switch to copper, right? And you became part of that task force which was working on it.
That's right.
Okay.
So, I started enjoying it after 6 months.
Yeah.
But soon after that 6 months, I started telling myself, where is my healthcare?
Where's my healthcare?
Where's my healthcare?
And then I thought, it looks like, it has a mission. And what they were doing was extremely exciting. And they needed to do what they needed to do. But I probably needed to go back to university to further study, and also I felt I would like to develop myself more.
Yeah.
Right.
Yeah.
And then the lab on a chip, healthcare, manufacturing, micro nano manufacturing, machining, that again put me back. And so I decided to apply for PhD. I talked to my same supervisor, Mustafizur Rahman.
Oh yeah, yeah.
Come back.
Take me back.
So he said, join back the lab. So I joined back the lab.
Mm-hmm.
So that's in 2006 that I so basically in 2006 January I quit my job there.
Yeah.
And I joined back the lab to start my PhD.
All right. And so, how was the kickoff of the PhD journey?
So the PhD journey started another interesting episode in my career, and it's a very exciting phase of my career. It's because in that lab now I had the opportunity to really work in a multidisciplinary setting.
Yeah.
Right.
Electrical, mechanical, software, putting all of these things together. And on top of that, the manufacturing process that Performance Lab was trying to implement is called electro-discharge machining.
Electro-discharge machining.
So in that process, what you do is you bring two electrically charged probes very close together.
Yeah.
But you control the gap using the motion controllers, such that the energy discharge between them is optimal and generates a lot of heat. And from that heat, you can actually erode a small amount of material, very hard material like SAS 304, stainless steel. You can remove that in a very controlled way. And that's very important because of that, for example, for microfluidic device.
Right.
So, so that was the technology that I was supposed to develop and implement.
Okay.
And I started working with another professor during my PhD. He was actually a professional at Panasonic. He was a very senior official, and Panasonic had initial investment in making this technology available for routine application.
Yeah.
So Dr. Masaki-san, right? I still call him San, right? So he was another inspirational figure, and I had the opportunity to work with him, and basically he motivated me to come up with a plasma physics model. And
now you're very happy because you're doing your physics. Your theoretical physics comes to play now.
So basically, he told me is that if we can have a mathematical model of that plasma, then it becomes much simple for us to design that electrical circuit and motion control system because we know the mathematical model. The current approach at that time the approach was that people are going, instead of going bottom up, people are going top down. And applying rule of thumb engineering principle is that make the machine first and see if the circuit is doing it.
So top down means deciding what the application is and then kind of working their way downwards how to do it.
Right. And then fine-tuning the machine. But it was not built up on the fundamental understanding. And what Masaki and he was trying to do is that can we come up with a better machine and better model, but in a bottom-up fashion, right? So once you understand the fundamentals first.
The physics, essentially, right?
So then Prof. Rahman and Dr. Masaki, I worked closely with them to come up with a plasma model of a plasma, basically a physics-based model of plasma.
Okay.
And that's something really I'm very proud of. As one of my
babies,
as you can say. And yes, I would say that's one of my babies. And interesting, right? Which is at that time, again, right? They just gave me the problem, but then I don't have a solution. And I know that the solution might be there somewhere. And if you can imagine, which is there is no exact match, right? But there are other industries where applying similar kind of thing, like for example, welding.
Right?
The welding industry, because again, that industry itself has its own challenge, so I'm not very familiar with that. But they had tried to do some modeling work. But some of the modeling work was applicable only to that field.
Right.
And this domain of micro machining was not referring to that. And all that I had to do is basically look through all of this and put together a sort of mathematical model that can predict the resistance of the plasma, the capacitance of the plasma, the
Okay.
inductance of the plasma.
Mhm.
And then using that, I could model the electrical properties.
All right. So this was the center focus of your PhD.
thesis.
What was the subject of the thesis like? What was the title?
So title itself was modeling electrical plasma
Mm.
in the electrical discharge machining.
Okay.
What came out of that research? Is it something applied right now? Does it have many citations?
So yeah, some of the work that we did
Uh-huh.
have a couple of hundred citations.
Oh.
Prof. Raman itself has significant amount of citations from this domain, right?
Yeah.
Because he was a pioneer in this area. What came up, right, which is basically the field itself,
Mhm.
right, progressed,
Mhm.
and a lot of micromachining and now is routinely applied.
Yeah.
But at the same time, the field evolved.
Mm.
Right? Like for example, together with the micromachining technologies,
Mhm.
the semiconductor manufacturing technologies and the MEMS microelectromechanical system manufacturing technologies also evolved.
Right.
Okay.
So, today the technique itself is applicable,
Mhm.
and it's applied for example, for different sort of industry. Like for example, in machining small parts and jet engines.
Right.
That's where it's applied.
Yeah.
But it didn't find the healthcare application that I thought that
Yeah.
it would find.
Okay. So let's contextualize everything.
But before you do that, I have,
Yeah.
I have a question. So, you're talking about PhD. We're undergraduates right now. I have asked this question to you before, but in your opinion, right, should you go for a PhD?
Okay, excellent question.
And how did PhD change you and your approach to academics?
So I think the PhD didn't change me,
Uh-huh.
having a PhD degree.
Mhm.
But I think what really matters is that that opportunity to think
Mhm.
with an open mind,
Mhm.
think about a big problem,
Mhm.
and think of a solution.
Mm.
Right now, you ask me whether students should go after PhD or not. I think fundamentally, right, people should go after this.
Yeah.
After.
Go after this, which is after thinking about identifying a problem,
Uh-huh.
Right.
matters,
And whatever it takes to solve that
and
problem.
whatever it takes, identifying a problem, going after the problem,
Mhm.
finding the right resource and right
Mhm.
support and right solution, conceptualizing it,
Mhm.
and implementing it.
Mm.
Yeah.
And in a way, PhD is the training ground for doing that.
Yeah.
Right? So if you have an opportunity from elsewhere,
Mhm.
you can do the same.
Mhm.
And the PhD certificate does not make you what you are, but basically the training.
Yeah.
Right.
So from that point of view, I think PhD training has its uh, own importance in it.
Mhm.
But more important is enjoying the journey in full and giving your best, whatever journey you are taking. Right?
Right.
If you're not joining a PhD, if you have the same opportunity from an industrial career, go after it. Do
Mm.
the same.
Mm.
Right?
Yeah.
At the same time,
For sure.
Mhm.
this world itself, you have some sort of recognition, acknowledgement, right? So if you implement, let's say you do what you need to do to get a PhD in an industrial career,
Mhm.
and if you do the same,
Mhm.
that's fine. But then you do not have a certification,
Right. Right.
and PhD provides you that opportunity to have a certificate.
Mm.
Okay.
So,
Mhm.
so I would recommend if you have passion for science and engineering career,
Uh-huh.
and if you want to, be a scientist or a innovation-driven engineering career, if you want to pursue, then I think a PhD would be helpful.
That really is true because I've noticed here at the office a lot. I mean, you know yourself, like everyone, perhaps not everyone, not me included, of course, but yeah, a lot of us have a PhD. They're holding a PhD, and I think it comes with is it a culture thing as well? Like
At MSD, you have a culture of recruiting PhDs.
I think MSD is a different situation then, right?
Okay.
So let me say this, which is, and then this is my opinion again, right?
Yeah.
Is that when you have first is you have a important, impactful problem.
Mm.
And then you will redefine it as important, impactful engineering problem, where we know the solution exists, but it's about innovative way and creatively putting it together, and more importantly, have the right value proposition,
Right.
right cost, right value structure, and that's an engineering problem. And then a science problem is another sort of problem where you're dealing with unknown. Unlike an engineering problem, the solution itself is not known. So the business that MSD in is a science problem. So basically, unlike an engineering application, like building a 400-meter tall skyscraper, here the problem that we're dealing with, like for example, unknown disease like non-alcoholic steatohepatitis, which is a liver disease, or a neurodegenerative disorder, dementia, for example. We don't know if the solution exists. We don't know what is the solution. We are going after an unknown. So in that setting, right, you need people, a lot more people who has that sort of training, right? That sort of training that can go after an unknown problem and creatively conceptualize a solution. So it's a different industry. So for a science-based and research-driven biopharmaceutical company like MSD, you need to have those kind of people. Right? Again, emphasizing again that it's not necessarily a PhD, but it's the trait that matters. Now, if you go after people, where can I find those talents? Then you tend to see that those who have that trait, they end up doing a PhD. And so that's how the scientists that you see on this site here, a lot of them have a PhD is because of that. That synergy.
Because, I mean, like even from your story, I can see there's that underlying theme of your passion for medtech, your passion for biotech, and you were constantly chasing that, which led you to the PhD.
That's right.
It wasn't like after bachelor's what, it was rather chasing what to do for medtech, and that brought you to the PhD, right?
Right.
So, now that we are talking of MSD, how did MSD come about?
How did you get in here?
Yeah, how did you get in? How did this opportunity present itself after your PhD?
Okay, there was not after my PhD, there was a small episode in between, right?
Okay.
That is another untold story, which is back in 2006, right? A-Star was setting up, labs in Singapore. There was a huge investment. So they brought in one of these experts, Sir George Rada, from Oxford, who was a pioneer in nuclear magnetic resonance technique. So medical imaging comes in, right? And he came in, and he was setting up the lab.
These are the early days of A-Star.
A-Star days, back in 2006, right? So Sir George first came and started this institute called Singapore Bioimaging Consortium. And they bought one of those first 9.4 Tesla animal scanner with, it's very high field, high magnetic field, strong magnetic field, and, huge amount of investment, cutting edge technology. And back in 2003, the Nobel Prize for physics was given to those people who invented MRI, magnetic resonance.
Oh, okay.
Sir Lauterbach and Peter Mansfield. So they got the Nobel Prize for that in 2003. We read about that. In 2006, Sir George from Oxford, another pioneer setting it up.
They're here.
And and Sir George moved from Oxford. I would be stupid if I'm not excited.
Right.
So I got super excited.
There was momentum there.
And then
the hot place to be.
So then I thought, forget about my plasma physics.
Okay.
Can you just do that? Can you say,
so that
step aside?
Not easy. But there's a story in it.
So was it like deviating from your PhD altogether?
It was, right?
It's altogether two different things that I pursued.
So you were doing simultaneously your PhD on plasma physics, and this was just because
during my
the legends are here, so I need to be there. Okay.
So during my second year in PhD, I went to a seminar.
Okay.
And in that seminar, it's a targeted seminar that I wanted to attend to learn more about biomedical imaging. And that's where I sort of came across a presentation, and the lab head was reporting into Sir George Rada. He is another very well respected professor, Xavier Golay.
Yeah.
So he was there. And then I talked to him. I expressed my interest for doing medical imaging.
Yeah.
And then he said, but your background is, something different. You're a mechanical.
Very different, yeah.
You want to do medical imaging, and I don't have a position. So I said, don't you have any position? He said, yes, I do have one position. So I said, so what is that position? So he said, I have a position for an IT guy. So
okay.
Okay.
why do you need an IT guy? So he said, those 9.4 Tesla machine is running on Linux operating system. And then I said, well, I can be the IT guy and I'm good at Linux. So he said, but how did you learn Linux?
Then
Here's the
your
thing.
first job.
My first job.
Okay.
So
Okay.
my first job was to work on Solaris operating system. And then, of course, for to just doing the programming, you don't need to learn that operating system that much.
Yeah.
But I figured that it would be so good back in 2005 or 4, actually. I deleted Windows from my laptop and installed Linux. And I'm fortunate that I did it 2 years back.
Wow.
I forced myself to be a pro in Linux.
Right.
So I was quite good at that time. I forgot now. I was good at
Wow.
and then Xavier Gule asking me, can you join as the IT guy? So I said, yeah,
Sure.
I'm ready.
I'm ready. I can be the IT guy. So then,
So was that luck or no? It was. I mean, well, I mean,
luck.
yeah.
2 years back, I just forced myself to learn that Linux system.
Deleting Windows is hardcore.
And then that
Wow.
landed me in this job, right?
Okay.
So my first day at the job, Xavier asked me, is that, so now you're here as the IT guy. Do you want to pursue your career as the IT guy or do you want to learn about MRI? So I said, sir, I'm here to learn about MRI. IT guy is the one that's going to pay for it.
It's just the key. It's just the key. But I'm in now.
Just to attach me with you.
So that was. I mean, I'm really thankful and grateful to Xavier Gole, and he created that opportunity. And he said, well, if you just do your day job being the IT guy, I don't care night job what you do, right? And night job, he gave me the opportunity to go after some neuroscience problem.
Oh.
Imaging. And during this phase, right, as you can imagine,
Yeah.
I was full time here, so I had to go back to my supervisor, Prof. Mustafizur Rahman.
Yeah, your PhD was also.
With the sad face that, sir, can I convert my PhD into a part-time PhD? But initially, of course, he tried to convince me, saying that, the behavior that you're showing is sort of subtleness, right? You are not settling your mind. You are going after one to another.
Yeah.
Be careful about it. Make sure you settle somewhere. Don't just jump between things.
Yeah.
He blessed me, right? He gave me that opportunity.
Okay.
Convert your PhD into part-time PhD. So it took me 6 years to complete instead of a typical 4 years.
Right.
Since the second year onward, it took me longer time.
Yeah.
But I joined SBIC Singapore Bioimaging Consortium as a full-time employee there. So my weekdays were enjoying medical imaging. Weekend was going back to enjoy the plasma physics.
Right.
It was tough, difficult journey for 4 years.
Yeah.
I had my first child, daughter during that time. So
Oh, wow.
So if someone was sort of deprived of their right, that was my wife and daughter. So I'm really thankful to them. But eventually, 4 years later, I finished that journey at SBIC as sort of my training period, as you can imagine, on medical imaging.
Yeah.
And my PhD. And I got the opportunity to join
E-Star?
MSD.
Oh, MSD. Okay.
Right.
Yeah.
So that's how I ended up being at MSD.
Yeah.
But just to be clear, so the one with Singapore Institute of Bioimaging and your PhD were completely different, is it?
Completely different.
Completely different.
There was no.
And you were with Singapore Bio Institute just because the Nobel laureates were there.
So, well, I mean, the reason why I joined is because that was something that brought me, not because of the Nobel laureate, but because it's medical imaging. And you're talking about biosignal processing and medical image processing. That's the thing I was.
That's what you were looking for, yeah.
So it's just resonated in my mind that I'm in the right field. I'm going to enjoy what I'm doing, and finally, all things comes together. So I'm going to apply my system modeling knowledge, signal processing knowledge, image processing knowledge for doing healthcare.
Okay, so the interest in medical image. Just curious, sir, but because you were doing something so different from your PhD, did you have that some uncertainty or a sense of fear that I might detract from a certain central path? Just curious, because some of us go through those same internal conflicts. So just want to know more about.
So that's a very important question, and I had that internal conflict, and I have this today. And anyone who is going to have a situation, be in a situation that should making a choice between A and B,
Yeah.
right, is really difficult because, and if they are having overlapping and, sort of pro and cons for everything that you have, right?
Yeah.
So I always had that fear because I was leaving my comfort zone of
Yeah.
being in semiconductor manufacturing technique and micro machining technique, and yet going after medical imaging. So during my, towards the last phase, right, when I was sort of wrapping up my PhD,
Yeah.
and here was at SBIC, I was thinking, where can I get an opportunity? Because uh, the amount of training I have for medical imaging may not be sufficient for me to land in a
Medical
good
imaging.
career,
Yeah.
imaging career.
Yeah.
But then, uh, and then on the other hand, I'm also not investing in the career, in growing the career where my PhD
Plasma
is,
physics
right?
and PhD.
But here's the thing, right? Which is if you believe in yourself and if you give your best
Mhm.
and if you go after your dream,
Mhm.
you may fail, but don't worry about it because success will
Right.
follow.
Right. That's really
There you go.
There you go.
There, you should
Yeah.
tagline that. Yeah, for sure.
Exactly. As long as you believe in yourself, don't worry.
One thing, right?
It's my mother's record, right?
Ah.
So I believe.
Funnily enough, right, regarding the tape recorder, instead of fixing it, I used to just pull out all the when I was younger.
I'm not saying I didn't do that, but my mother was waiting to listen to the music, so
Okay.
trying to put it back.
Yeah.
Okay.
I have one question, and that is so. The reason I'm asking this is because I personally I'm coming from a chemical engineering background, and I feel a little bit of connection with you, given that you came from a mechanical engineering background. So just for context, everyone, Asad now is a site lead here at the Biopolis site of MSD. You're leading 3 teams that are under you. Each are essentially focusing on a different disease or even a different stage of biology, right? So, how did you adapt in terms of learning the biology, getting familiarized with it to a point where you could lead and guide us through projects?
Right.
Let's go to that question, starting from your journey at MSD. So, how did MSD kick off, and how did you actually land here? Because I'm presuming this answer will have a lot of learning curves that came along the way, right?
Sure.
Yeah.
So I think the mantra is very simple, right? Is as simple as this: is that don't stop at your comfort zone. Set yourself to have big dreams and tell yourself that you can do it, believe in yourself, and go after achieving it. So that's what it's really what I apply in my day-to-day life. So going back to the journey, right? Which is then back at SBIC, I started doing neuro imaging at night. Very soon, the IT job became just a routine stuff. Right? Eventually, things were settled down. The machines were unstable initially. Over time, I managed to put systems up. Things were there so that it becomes a stable machine. And eventually, all that I had to manage is user accounts because it became a very stable thing, right?
Right.
And so the job kept paying me, right? But I went after pursuing neuroimaging. And I started working on neuroimaging, and then there were some interesting biology at that time that I started learning. Right? So you talk about biology. So, I was working on hypothalamic signaling and regulation of our appetite and hunger.
Okay.
So that's what I started working on. So hypothalamus, if you think of it, is the analog to digital converter of our brain.
There you go.
So
That's the link.
again, right? So that's how we get to manufacturing it. Why I say that is because hypothalamus is the region in our brain that senses a lot of protein and hormonal signaling
Oh.
on the peripheral side, and not through the vagus nerve, not through the peripheral nervous system, but directly into the central signal system. So what it means is that hypothalamus must have an analog to digital converter.
Yeah.
Instead of sensing from the nerves, it senses directly from the blood.
right?
So, okay, I can reconnect with your physical interaction versus
Chemical, physical interaction, all that's coming back now.
So kind of like if hypothalamus, I'm guessing you're gonna say was kind of an answer to that, is it?
Exactly.
Ah.
Right. So to me, hypothalamus is a sort of biological system is a wonderfully designed machine, right?
Right.
It's so complex, isn't it? It's very, very
it's
complex.
a very, very complex machine.
Mhm.
And within that machine, that hypothalamus I was working on, right?
Uh-huh.
So I started working on that,
Okay.
and that sort of got me interested in peripheral signaling.
Yeah.
How brain gets peripheral signals,
Mhm.
central processing,
Mhm.
and how neuroimaging can actually discover and help us to investigate some of these, functional biology or
Okay.
physiological biology.
Yeah.
That's why these equipments are really, really powerful because
Right.
physiology is something that you need these devices
Yeah.
in normal anatomy, right? You can actually, look at the tissue itself or the anatomy itself.
Mhm.
But physiology is only happening when the thing is living,
Right.
right? And that's why this was very, very important.
Mhm.
And that got me, to learn more about neuroscience
Mhm.
and neuroimaging together, right?
Yeah.
So when I
Mhm.
joined MSD, I was actually hired to do neuroimaging and work on neuroscience pipeline.
Okay.
Right.
Oh, that's okay.
MSD at that time was working on pain. And interestingly, pain has connection with olfaction. Again, the chemical signal processing and all of this, right? So pain has
Olfaction is smell.
olfaction
Smell.
smell.
Pain as in physical pain has connection with smell.
Smell. And the reason why
Okay.
is because it uses the same channel for transmitting the signal to the brain, right?
Oh.
So it's the
Okay.
analog to digital converter.
I mean, pain and smell have a connection, as in.
So the peripheral pain signal, let's
Uh-huh.
say if you have pin prick in your hand,
Uh-huh.
that signal is
Oh, uses the same system as the olfactory.
same voltage gated sodium channel.
Ah,
right?
okay.
Oh.
For transferring for basically the
Alright.
signal uh, propagation and transduction
Mhm.
and receiving it in central processing system within our brain.
Yeah.
It uses the same channels.
Yeah.
Ah, okay.
So
Right.
I was working with non-human primates
Mhm.
to work on pain, and then was working on the screening compounds to find out potentially efficacious compound that can block our brain
Mhm.
for severe pain, basically, right?
Okay. So this painkiller essentially.
Painkillers, but as you can imagine, those who have undergone surgery, they will tell you that there is no efficacious painkiller.
Right.
Right.
And if you
Right.
work in that domain, you will see sometimes you may have seen the doctor just gives you a
Anesthetic.
anesthetic is one, but 1 to 10 smiley faces, right? And says, "Can you tell me your pain score?" And
You're sitting there like, ah, 5.
so what we're trying to come up with is that is there a way that
To have zero pain while undergoing surgery.
that's the objective of the drug, right?
Uh-huh.
And I was coming from a biomarker perspective. My role was
Oh, okay.
scientist is that instead of using that pain score on that, smiley is 1 to 10, which is very subjective.
Yeah,
Same
it's true.
cannot be produced.
Right.
Yeah.
Right? So can we utilize functional magnetic resonance imaging technique to read the signal directly from the brain?
So you are quantifying pain in terms of signal
Signaling.
and
Yeah.
trying to see a measure for
And
that.
trying to say a measure for that. And then our company was working on coming up with efficacious compound for that,
Mhm.
and was also screening and basically working with the teams to see if those compounds are efficacious, right?
Okay.
So that was my first job I landed on.
Alright.
And why olfaction came was that then,
Uh-huh.
in addition to pain, can I also look at olfaction? Because if it blocks pain,
Yeah.
the drug is also going to likely to block olfaction.
Right.
So I started doing neuroimaging for
Mhm.
pain and olfaction.
Mm.
That's what
Okay.
I spent my first 5 years at MSD.
First 5 years. This is from 2012 till 17.
2007.
17.
Right. And all along you were on that one single project.
So yeah, on those lines of projects, I work with non-human primates, work with human subjects,
Uh-huh.
and
Coming from the, as you said, biomarker, as in trying to map pain physically, right?
map pain physically. Or if you think about biomarker, right? Biomarker is about coming up with the objective measure of the biological process that is happening in the body,
Hmm.
right? So you, instead of subjective measurement, you have a quantifiable, reliable, reproducible objective measurement.
That's the ideal of a
That's
biomarker. Yeah. I mean, which is what we're trying to figure out now with all of the diseases that we're researching.
That's right.
All right.
Just quick question. I'm really curious. Is sense signaling also sort of subjective, or is it less subjective
The
than?
pain signaling.
Yeah.
yeah, the signals
I mean,
are
some
subjective
people-
as well. Yeah.
That's right. So pain signaling is also, here's the thing, right?
Right.
So part of the pain signal is actually detected by two different brain regions, right? One is the thalamus,
Mhm.
right? So we call it as thalamo. Okay, well, one is, sorry, got it, right? One is to our, brainstem, right?
Mhm.
Okay.
So, and cerebellum, right?
Mhm.
That's a direct signaling pathway,
Okay.
right? And then there is a second signaling pathway, which is basically uh, is received from the blood
Mhm.
and goes to thalamus.
Mm.
All right.
From thalamus, then there is a projection both from cerebellum, which is the back of the brain,
Mhm.
which is basically connected to the peripheral system,
Mhm.
and thalamus, which is a sort of a uh, signal processing domain in
Yeah.
Right.
term, right?
Right.
Yeah.
It receives the signal,
Uh-huh.
it processes it,
Mhm.
and then it projects to cortex.
Okay.
Oh, okay.
And cortex and prefrontal cortex specifically, a person assigns that pain score, right?
Right.
Some people are actually, strong against pain.
Mhm.
That means the thalamus might be recording the same amount of pain, likely.
Okay.
The projection to prefrontal cortex is saying, no, no, no,
Uh,
I can take it. I
so
don't
your
have-
challenge
So
is to
the-
catch the signal at the thalamus.
Before the ego
Yes,
comes in and
before
says,
the-
I can do this. Oh, okay.
Ah,
So I was trying to look at
interesting. Yeah.
all different brain regions.
Yeah.
And see if we get a more robust, and so we are looking at nearly 100 to 200 different brain regions,
Mm.
Uh-huh.
and quantifying signal in every single zone
Uh-huh.
to see which one has a strong correlation with actual pain that sort of
Okay.
inflicted.
All right. So we have covered until 2017. Let's begin with after that.
This is where I believe this is where you embarked on your journey towards biomarkers in general, expanding your scope, right?
So yeah, from neuroimaging biomarker, then so in 2017, I think I'm thankful to another person who is Chilian, who is my current boss. Right?
He might watch this, right?
I'm not sure.
Actually,
I
So I had an opportunity to. So okay, I've been at MSD, and one single person that I have to be thankful, that would be Chilian, because he's the only manager that I've worked for last 11 years.
oh,
So he has been
okay.
a single manager, and he was the one.
That's quite a long relationship over there.
And
for sure.
right, I want to highlight that he was the one who believed in me, right?
Mm.
Because when he was hiring,
Uh-huh.
right, MSD being a multinational company, you can imagine that there would be hundreds of applications, right?
Yeah, yeah.
And he believed in me that I'm coming from a plasma physics PhD.
Yeah.
Uh-huh.
So my PhD doesn't match with this domain,
Uh-huh.
with some experience in doing biomedical imaging.
Mm.
And he thought I can do it.
Okay.
And he gave me that opportunity to join here. So I'm really thankful for that in 2012, that he gave me that opportunity to join and do neuroimaging.
Mm.
Okay.
So, and then in 2017, fast forward, right, that opportunity turns out to be a leadership opportunity, because Chilean decided to move from Singapore to the US.
Uh-huh.
Right? He actually came from US to Singapore. He stayed here for 5 years,
Mhm.
and then he wanted to go back.
Mhm.
When he wanted to go back, right, he gave me this opportunity to
He handed over the reins to you, is it?
part of his team, smaller
Okay.
Okay.
to me, and that was another great opportunity, because that's when I started thinking that broadly beyond that healthcare, but at the same time, my passion being a scientist,
Mhm.
but yet the passion of doing something for the world, right? Of course,
Right.
I haven't done much for the world.
Uh-huh.
We're still pursuing our dreams. We do have big dreams, right?
Mm-hmm.
And that's what we said. Everyone should have. If
Right.
you don't have, please have a big dream.
Get one.
Get one.
Get one.
Get one and go after it. Right?
Yeah.
So that's important. So, But at that time, he opened up this opportunity, the leadership opportunity, right?
Which is the Singapore site
The
lead.
Singapore side. So at that time, I was not the part of the Singapore side back in 2017. I became a group leader for a smaller part of the group. So he handed over his imaging biomarker team to lead the imaging biomarker team.
The Singapore one, or
Singapore, right? And then he went back. I still report to him, and so Singapore team had imaging biomarker led by me, and then there was a molecular biomarker team, and then he also have another imaging team in San Francisco. So that team in Singapore, when that opportunity came, it all fell together. Now it's all about
the
people, leadership, and then the question is now what I believed at that time in 2017, and over time in 2019 I became the
Singapore site.
site lead. One of the site lead is the site coordination team. Is managed by 4 people. I'm one of the site. Now, I took that opportunity, got that opportunity in 2019. But basically in 2017, right, when I started leading the team, that's when I felt the strong passion for not only doing something for healthcare, but connecting people to opportunities, connecting people to strategies, and leading people to a direction where they can achieve, they can set big dreams, right? They can set big goals, and they can achieve it. And if I can be part of their journey, that's my, that's my achievement in life, right? That would be my babies again, another.
For sure.
So that's when I started, leading people and took on this people manager role. And I can tell you it's something that I really, really enjoy. I truly enjoy.
Did you ever have a leadership position, or was that something that came natural to you, or you picked it up and you just rolled with it?
So, well, I didn't have a leadership role, or let me put it this way, because leadership and people manager is confusing, right? These are two different elements. So I didn't have a people manager role before 2017.
You were a technical.
I was a bench scientist, individual contributor, we call it. So I was a scientist doing my stuff, going after the humans to do the olfaction imaging, going after the monkeys to pain imaging. But basically, I was doing it, DIY, do it yourself. So that was my thing, right? So I didn't get involved in people manager.
Right.
I think if I think of your question slightly differently, is that what was the leadership element? And I think the leadership element is slightly different. Leadership element, what I feel is that you do not need to be assigned to be a people manager to be a leader.
Right.
Leader's job is not to manage people. And in many cases, successful leaders were never appointed. Right. Nor that they went after and say, call me as a leader. Right. It just happened naturally. Why? It's because there is a single attribute. That attribute is being enthusiastic about driving a change for better tomorrow. Right? So if you look at any leader's life, you will see that those people they can't stand still. They go after, they have this magnetic eyes, they go after finding problems.
Right.
And challenging problems. And problems that needs to be improved upon for a better tomorrow. So they go after those. So basically that's leadership, right? So you find something that's impactful and go after it. So I am the people manager role.
How have these past 4 years been then? 2019 was your last major pivot, right? Into this leadership, people manager role, into being the director. How have these past 4 years been?
It's in single word is exciting, right? But if you allow me to add a second word, then I will say it's challenging. Right?
I can imagine.
To redefine myself, but going after healthcare, right? And going after patients, going after trying to do something that impacts human life. So keep that end in mind, right? And don't deviate from that. So basically, MSD as a company is a wonderful place to work and really a great place to see where you can see that the senior leaders actually walk the talk. Right? So they
Right.
go after the patient first, profit follows. They go after cutting edge science. They really go after uh, impacting human life, transforming their uh, life by having disease modifying therapies, right?
Right.
So uh, so being part of MSD, that comes naturally, right? Because the organization provides that support. But together with that, I think the journey, the leadership element, I had to redefine myself, right? When I was now thinking about my own success, that had to be transformed into
The success of your
success
team.
of my team,
Yeah.
showing the
That's right.
team, helping the team to be on the right track,
Right.
guiding the team and being part of the team to the journey, right? To navigate unknown territories, uncharted path.
Yeah.
That's where the last 4 years I've been.
Okay, and at present, across these 4 years, you have been overseeing 3 projects, right?
Three teams, multiple
teams,
projects. So we
multiple
do a lot of
projects.
things, and that's
Could you walk us through that, like all that you do, all that you have done across these 4 years, and all that you oversee?
that's gonna take a whole podcast in and of itself.
But just a brief overview for our
Sure.
viewers, yeah.
Yeah.
So yeah, I think that 4 years, right? Suddenly today is not where I started. Right?
Okay.
So I think during that 4 year, right, I learned one thing is that you also need to do right thing at the right time.
Yeah.
And one of the innovation, technological innovation happened is AI machine learning.
Oh,
Right?
Yes.
Back in 2003 or 4.
I'm interested where this is going, how AI and machine learning kind of. Yeah.
So back in 2003, 2004, if you think about robotics, right? Neural nets were applied because you wanted robotic balance, right? If you think about how a human balance it's amazing how a human can balance, how a baby is able to walk, right? Because if you have robotics background, one big challenge is you can never find a robot has a baby foot
Yeah.
able to stand.
Right.
Look at the foot of the robot and see how big pedestal is needed for it.
Yeah.
And so that balancing problem, it can be solved mathematically. It can also be solved using modeling-free technologies such as AI, neural nets, right? So back in 2003-4, we were trying neural nets, and then there was a dip. It's because technology was not mature.
Right.
Even then, there was actually IEEE came up with this thing that there is nothing called artificial intelligence. It should be called as computational intelligence. So back during my PhD, I took modules such as computational intelligence because artificial intelligence was not surviving, and started applying, implementing different techniques like genetic algorithm and things like simulated annealing technique, which still exists today.
Yeah.
But that was the computational status at that time. And in 2017, right, NVIDIA and GPU computing,
Oh yeah.
that just made a whole new paradigm shift happen. And in 2017, when I became a group leader, right, my first thing was that, well, I'm going to do what we have been doing for sure. But here's the thing, here's this transformation happening. And I had some initial experience that why image processing, why sophisticated computing did not work well in 2004. And now this GPU computing is offering us this opportunity. And this is the time where all of these things like healthcare will heavily utilize AI machine learning.
Yeah. Yeah.
And then I thought that our team should do AI machine learning, advanced analytics, data analytics, in addition to image processing. And images are data, right?
Right.
It's a data, and if you talk about a lot of images or videos, there's a big data.
Yeah.
And big data means you have an opportunity to apply AI and machine learning because big data is computationally complex, is data rich, and that's really where you can apply AI machine learning. So I thought our team should start working on that, right? That's a journey that was 5 years.
And that translates into the multiple projects.
Yeah.
Today, what the teams are working on.
So that's quite. You're kind of an AI leader in medtech, if I may say so, right?
Actually, that's
Pharmaceutical industry.
for sure. Yeah, because I spoke with another person at the company the other day, and then he was essentially saying that the big buzz right now, ChatGPT, AI, artificial intelligence, that's like that boomed maybe around last year, right? And then a couple of us, we were asking this expert. He was within the company, and we were essentially asking like, are we doing something with AI? But these people were coming from not our team, yeah, so they didn't know what we were doing, right? And then he spoke on the behalf of like the AI teams and everything. Essentially, we've been doing it. We were ahead of the times because we were doing it back in 2019, 2017. Yeah.
Oh, okay.
So that's why we're not advertising that this is something that we're starting to do, because it's already something that we've been doing for the past
Yeah, as you said,
7
2017
years.
itself, you started
So we started.
inculcating these new techs into.
So that's right. So we
Yeah.
thought that. So if you think about conventional image processing, so
Right.
we are using analytics
Yeah,
and a lot of it.
yeah,
But those analytics were typically mathematically modeled.
Uh-huh.
So basically,
Right.
we're going after model-based analysis technique,
Right.
and then this AI and machine learning comes and sits on where mathematical modeling techniques are not sufficient.
yeah,
Or you can discover much
Okay.
more, right?
Right.
And it just like it's a lot to say. But if you think of it, which is the amount of data that you can have in a in an image now, right?
yeah,
That was not possible like 5 years back.
Right.
Yeah.
Because of the technological advancement. AI and machine learning is something that is mandatory for you to mine that information.
Ah, right.
So if you think of it, right, which is if you divide a medical image into like a Lego blocks, right?
Uh-huh.
It would be those Duplo blocks in the past,
Yeah.
right? And you have like the nanos now,
Uh-huh.
which is the
Um,
tiny one. So
Right.
there's a tremendous growth in technology.
Mhm.
That tremendous growth has tremendous growth in the data.
Okay.
But if there's data, but if you don't have the analytics that is matching the data,
Yeah.
that's a gap. And,
Right.
and we saw, from our Singapore team, we saw that gap and we wanted to go after that.
yeah,
Okay.
And, it was not easy, right?
Right.
Because it's something that we wanted to start pursuing from here. But I think, we are fortunate to be able to put it together. And right now, our team is heavily involved in AI machine learning,
yeah,
for digital pathology, for big data, for biobanks,
Uh-huh.
for radiological images, retinal images. In all of it, we are applying AI machine learning routinely.
Okay. I mean, yeah, mathematical models were okay for Lego blocks, but when they become nanos and millions, that's where AI and ML come and sit on top.
Exactly.
Right.
Would you say
Okay,
that this
so-
is like your what's the last thing?
Yeah.
Would you say that this is your defining mark on the
Yeah,
MSD,
right. Do you see it as like your defining moment?
your achievement within this
Okay,
company?
Well, I mean, I love MSD, right?
Uh-huh.
And if I say this is my achievement, then I might undermine my future achievement because
That's right. That's right.
what we said at the stage is that you know dream for a big goal.
Correct.
So I think my
I mean, your role in itself is quite defining because you are essentially the pioneer for inculcating AI, ML, and all of these new tech into healthcare, right? So it's already quite pioneering and defining. Yeah.
So from MSD perspective, yes, we had a great opportunity to play a role, right? I wouldn't say I'm the single person because it's a big organization,
Right.
but within cardiometabolic disease now, neuroscience is now going into cardiometabolic disease. That's what we applied and we pioneered within biomarker area,
Yeah.
MSD, and from the translational biomarker point of view, I think our team has done the pioneering role. Of course, the organization is pretty big, right? There are other teams and groups that also pursued super exciting, fascinating, fronts of this in space.
Right. Right.
So
All right. So that was quite a journey.
Definitely.
Now that we draw to a close, sir, what would be your reflections? Reflections for our viewers. And
Takeaway messages, I would say.
Yeah.
So it's like
reflections and takeaway messages. And what would you want our viewers to kind of snap in their minds as we draw to the end?
So I think, if you are, wherever you are listening to this podcast, right? And listening to our conversation here, I think a few things comes to my mind as reflection, right? the first thing that comes to my mind as reflection is that believe in yourself, right? And think that if anyone else can do it, I can do it too.
Mm.
And the moment you think that, right, it just changes the perspective completely. Because a challenging task is no more challenging. It's because you embrace it, and you don't push it away, right? So really, that first step of setting that mindset that, if anyone can do it, I can do it too. And I tell myself that if anyone can do it, I have to do it. So go after that, right? And then the second thing is the moment you now say that, right? And if you do that in the context of a challenging, goal, an impactful goal, it's important to make sure that impactful goal, right, has a purpose.
Yeah.
Right. So if you have a purpose, then only you will be able to withstand the challenge that is coming.
Yeah.
Right.
Yeah.
If you do not have a purpose, then tomorrow you will feel frustrated.
That's
So it's
right.
important to have that purpose. So young people, right, in your early 20s, if you have a mind map, what your day would look like, what your past would look like when you're 65, and when you're thinking about it when you're 21, right, that would be something phenomenal. Because you will put your end in mind that what is that purpose, what is that you want to achieve, what is that you want to be known for when you're 65. Right? So if you're able to put that, I'm not 65 yet, but I'm trying to
You look way younger, so.
So,
Yeah.
but that's the second thing, right? Which
Yeah.
is you put that, and if you know that purpose, then the third thing, which is the challenge along the journey, right? It's all about sweat and tears and hard work and dedication, hours and hours of dedication and investing your time and effort. You're only going to be able to do that in the first 2 years, right?
Right. Right.
So
That's right.
go after that end in mind with the purpose, but at the same time put in the hard work so that you reach where you want to go. And along this journey, right, there are elements that I think I would like to reflect upon a few things, which is in this journey, right, it is only a good purpose if you put human race, other people, others, right, ahead of you. So that's really important and critical because if your purpose is just to do self-satisfaction, right, at your 65, you may not look back and you may not feel that you are something proud about, right? If you put others first, then you will see that that purpose is really sort of resonant for the investment that you're going to make, and when you're reflecting back, that's something that you will be proud of. So put others first, right? And then the second thing is, you know, be so you have enthusiasm and you have the integrity, right?
Yeah.
So you put others first, but really have that authenticity and integrity as you lead people, as you work with people, right? So that integrity is extremely important because now you have a purpose and you have a strong integration so that you can influence people, you can convince people, you can influence yourself that this journey is worth taking.
Yeah.
And then the last thing is, holding a strong humility, right? Because along this journey, I think it's important that no single human being can achieve. It's not about being a superhuman, but instead, let's come together and let's achieve a, unfathomable task, right?
Yeah.
So when you go after that, I think the element that really comes is that are you able to give credit to people?
Yeah.
Are you able to accept your mistake?
Yeah.
Are you able to say that, things that you're not capable and others are better than you, right? Are you able to accept, recognize that, and really give due credit to people? So that humility element is extremely, extremely important for our journey.
Yeah.
And then with that, I think,
Yes.
Wait, wait. So I want to this last segment, right? Thank you, Asad, for everything that you've said. It's been, I feel inspired, and I'm sure that for those that do end up watching a part of it, maybe the whole thing, right? They will also feel inspired as well. So I want to throw a treat to those viewers that have gone this whole journey with us, right? And I want to ask you, right, as someone who, as a leader, right, what type of person do you look for to join your team? So, right, you see what I'm doing here?
Okay,
You see what I'm
I
doing?
think this segment will have the highest number of views.
So this is
Who
essentially
are the people that Dr. Asad looks for in his
TMRC
Yeah.
hiring cheat sheet, essentially.
So I can hire TMRC, or TMRC is our local site here.
Yeah.
Uh-huh.
So let's say it's not TMRC hiring cheat sheet, but let me say that it's a imaging
Biomarkers chairs hiring cheat sheet. Okay.
So I don't hire all the people, they're team members, they make their own decision.
Uh-huh.
But I think one thing that you may need to pay attention to is demonstrate during your interview, during your interaction, and during your journey.
Mhm.
Try to demonstrate that you're passionate about doing something.
Mm.
You are dedicated to driving your passion forward,
Mhm.
right? And you do and you give in your best,
Mm.
right?
Yeah.
And then the rest, right, which is the academic results, um, your other achievements, those things follow. The moment you put these three things forward, right? And if you demonstrate these three things,
Mhm.
I mean, that's the best, and that's the person that I look forward to,
Okay.
right, in having.
So you look for the conviction and the attitude. Other things are fine, like grades and other. You're like okayish about it, but you look for the
Even
attitude
experience,
first.
right?
Experience, yeah, that's right. So I would look for experience too, but sometimes you may say, well, I don't have experience. How do I gain experience?
Mhm.
If you need to have experience to get experience,
Yeah.
right? So,
Yeah.
so I technically I tend not to look for experience.
Mhm.
If they have, it's
Mm.
good. Like for example, as a fresh graduate, right? That's
Yeah.
what I'm talking about.
Mhm.
In those entry point roles.
Yeah.
I think experience is important. If you have it, is good.
Mhm.
But rather, I would be more interested in listening to how did you land in that experience
Mhm.
and how did you impact. Even that experience, if it's not related,
Yeah.
I'm fine
Mm.
because I would like to hear your story.
Okay.
So that's what I think. That's what makes the difference.
And that's true. So Assad really isn't lying in this in this sense, because even though Assad himself didn't interview me during my internship interview, from obviously later on, I got to know that the those people that were interviewing me that day, 7 months ago at this point, right? They were looking for a passion, a drive, because again, coming from a chemical engineering background, I didn't necessarily have the strongest grip, but I did. I'd like to think at least that I showed something, a potential that I wanted to realize, and you gave me the opportunity. So thank you, and I think I'm proof of that actually, of what you're saying for sure. Like
I mean, we worry so much about marks and all, but I guess across the panel, conviction is what you really center on, right?
That's right. I mean, the thing is this, right? Some people go after marks,
Yeah.
right?
yeah,
And I think in early phase of university, it's important to have good grades because good grades lands you in good optional subject, good
for sure.
internship. But if you just go after grades, right,
Mhm.
your end point is not right.
Yeah.
End is to have an in-depth understanding, discover yourself, and discover your passion, and link them together.
Hmm.
Your knowledge about that field, your passion, and your knowledge about that field, your self-discovery, and your passion for that.
Hmm.
Right? So these three things together, that's what a student is supposed to do.
Right.
Now, these three things together, if they're in perfect synergy,
Mhm.
good grades follow.
Right.
Yeah.
But at times, there's this thing called exam temperament, right? I'm just
Yeah.
not good in exam. That might happen.
Yeah.
Right? And people may not score good grades, but they are on track with endpoint.
Yeah.
Right?
Yeah.
The end in mind. But if say someone is just going after good grades, but really missing these three elements,
Mhm.
highly unlikely that they will be successful in their career.
Highly unlikely they'll be at MSD. Okay, so on that inspirational note, and of all the great things that we have covered, we draw to an end. Thank you so much,
Thank you
Dr.
so much,
Asad,
Asad.
for being with us. Thank you so much. We were
Thank you
truly
so
honored to
much.
have you.
Thank you so much, and thanks for having me.
Yeah.
And thanks to the viewers.
Okay. Thank you.
Thank you.